India's space story did not begin with rockets. It began with a philosophy. In 1969, when India was still struggling with poverty, food shortages and limited industrial capacity, Dr. Vikram Sarabhai founded the Indian Space Research Organization, ISRO, with a radical idea. He believed space technology should not be about prestige, it should be about people. From day one, ISRO's core philosophy was clear: low-cost innovation, indigenous technology, weather forecasting, communication, education, and disaster management. This was not a copy of NASA or the Soviet space race. This was a uniquely Indian model. ISRO's early milestones were modest but historic. In 1975, India launched Aryabhata, its first satellite. In 1980, PSLV-3 placed a satellite into orbit using an Indian launch vehicle. Then came the real revolution. INSAT transformed weather forecasting and television communication. IRS satellites made India a global leader in remote sensing. What made ISRO stand out was not a glamour. It was engineering discipline. By the early 2000s and into the 2010s, ISRO entered its most respected phase. The PSLV became one of the most reliable launch vehicles in the world. In 2017, ISRO launched 104 satellites in a single mission, a global record at that time. In deep space, India achieved something historic. Chandrayaan 1, launched in 2008, confirmed the presence of water molecules on the moon, a major scientific discovery. Then came the Mars Orbiter mission, launched in 2013 and entering Mars orbit in 2014. India became the first nation to reach Mars orbit on its first attempt. The mission was the lowest cost interplanetary mission at that time. Importantly, this achievement happened under the leadership of Dr. Manmohan Singh as Prime Minister. His government maintained a culture of scientific autonomy. By 2014 and 15, ISRO had something rare: global respect without arrogances. What followed was not a downfall, but stagnation combined with rising failures. Several structural issues began to appear. First, increased political visibility. More announcements were made before missions were technically ready. Deadlines became public commitments rather than internal milestones. Second, a budget versus ambition gap. ISRO's annual budget has remained around $1.8 to $2 billion, while expectations expanded rapidly. Human spaceflight, heavy lift rockets, space stations, reusable launch systems. These are NASA-level ambition on a mid-size research budget. Third, brain drain. Talented engineers increasingly moved to private Indian startups, foreign space agencies, better paying R&D sectors. Recruitment cycles inside ISRO remained slow and bureaucratic. Fourth, bureaucratization. Risk-taking reduced. Internal dissent essential for science declined. Decision-making became more cautious and layered. Failures are normal in space science, but patterns matter. ISRO faced several verified setbacks. GSLV cryogenic engine failures delayed heavy lift capability by years. Chandrayaan 2 2019 failed its soft landing, though the orbiter succeeded. SSLV D1 2022 failed due to software and sensor errors. NISR, the joint mission with NASA, saw delays. None of this alone defined failure, but together they raised serious concerns about quality control and system stress. Let us compare. NASA operates with around $25 billion per year. China's CNSA is estimated at 12 to 15 billion. ESA spends 7 to 8 billion, whereas ISRO operates at less than 2 billion. Despite this, ISRO still competes. It excels in cost efficiency, Earth observation, satellite launches for developing nations, indigenous navigation systems like NAVLC, but where it lags is human spaceflight readiness, reusability, rapid innovation cycles. ISRO competes despite constraints, not because of equal support. There is no proven evidence that corruption inside ISRO caused mission failures. ISRO remains one of India's cleanest scientific institutions. However, public perception of corruption in broader governance, budget leakages, and misallocation of national priorities do affect funding and long-term planning. When science funding stagnates while expectations rise, institutions suffer silently. The issue is not lack of talent, it is about lack of sustained institutional support. Is ISRO really failing? No. But it is being overstretched. ISRO is being asked to perform like NASA while being funded like a modest research organization. But still, Chandrayaan 3 restored confidence. The private space ecosystem is opening through InSpace. LVM-3 is stabilizing. But for real progress, India must ensure scientific autonomy over political messaging, higher R&D funding, faster hiring, reduced bureaucracy, strong public-private collaboration. Space science does not fail because of rockets. It fails when education is replaced by emotion. A nation that celebrates announcements more than preparation will struggle to sustain excellence. ISRO's story is not about decline, it is a warning. Talent alone is not enough. Ambition without support creates burnout. Pride without patience creates stagnation. ISRO didn't slow because of lack of brilliance. It slowed because ambition outpaced support. The future depends not only on scientists, but on citizens who value education, accountability, and long-term thinking.